Let's have a look at question 14 in this video. So Paul is coming up to a statistics exam without preparing for it. The exam has 20 true or false statements. For each correct answers we have 1 point, and for each wrong answer or no answer there are no points. Now to pass the exam we need at least 11 points, and we also know that the probability for each statement of being true or false are equal. Now Paul decides to answer the statement by throwing a fair coin. So if the coin shows heads, Paul answers true. If it's tails, he answers false. What's the probability that he passes the exam? Now let's understand what we're working with. We're working with probabilities. What kind of probabilities? Well, we have a probability of having a correct answer, and we have a probability of having an incorrect answer. Because the correct answer could be true or false, and the incorrect answer could also be true or false. And we also know that those probability of being true or false are equal, meaning that the probability of having a correct answer is equal to the probability of having an incorrect answer. So that's going to be a 50% probability, and this one is also a 50% probability. So the probabilities of these two are equal. Now when we're dealing with two options, a probability of a correct and a probability of an incorrect answer, we're dealing with a binomial distributions because we literally have two options. So we are going to have the binomial distribution. Now what we're interested in is the probability of passing the exam, for which we need at least 11 correct answers, meaning what we're looking for is the probability of having at least 11 correct answers, 11 successes, so to speak, given that we have a sample of 20 questions, meaning 20 options, with the probability of success, with the probability of a correct answer being 0.5. 0.5. And the question is, what's that gonna be? Well, we're gonna work with the binomial distribution by looking at the table. So we would have the following. We would have the probability of x equals to 11 plus the probability of x equals to 12 plus the probability of x equals to 13 plus the probability of x equals to 14 plus the probability of x equals to 15 plus the probability of x equals to 16 and probability of x equals to 17 and probability of x equals to 18. That's as far as we can get in the binomial distribution table. That's all the probabilities that we have available, so we'll add them up. And once again, one thing to keep in mind, we take into account that we're checking for the sample of 20 with a proportion of 0.5. So these values are going to add up to the following. Here we have the probability of x equal being 11 is going to be 0.1602 plus the other one, x equals 12, is 0.1201. Probability of x equals to 13 is 0.0739 plus the probability of x equals 14 is 0.0370 plus the probability that x equals to 15 is 0.0148 plus the probability that x equals to 16 is equal to 0.0046. Probability that x equals to 17 is 0.0011, and the last one, probability that x equals to 18 is equal to 0.0002, so it's almost zero in the end. And the reason we don't have the probability for x equals to 19 and for x equals to 20 is by looking at this pattern. We can see that as we have the probability of 18 successes, 18 correct answers, by guessing out of 20, that's becoming really low because it's very unlikely to guess so much. That's the intuition here. Now what we need is to add these probabilities and see what's that gonna be. So if we do the math over here and we add all these numbers, we would get the following. We would get 0.4119, which is approximately 0.412. In other words, there is a 41.2% probability that Paul is gonna pass the answer, that he's gonna have at least 11 correct answers. So the answer key gives us that probability is 0.16, which is false. And that's it, we are done.